Last time, we hit a wall. You can't just make these models bigger forever. So, researchers reached for a second dial, and it turned out to be almost as powerful as the first. Not a bigger brain, more time to think. And it changed what these systems can do. We've traced Claude from how it's built all the way to scaling laws, the rule that says bigger keeps getting smarter until it starts to run out. Today, what you do next, reasoning models and something called test-time compute. The idea that a model which pauses to work through a problem can beat a far larger model that just blurts out an answer. We'll cover what thinking actually means for a machine, why showing its work helps, how it's trained to reason, why this is a whole new way to scale, and the catch that comes with it. Start with how a normal model answers. You ask a question, and it generates a response one word at a time, immediately. No pause, no draft, just straight to the reply. For simple things, that's perfectly fine. For a hard math problem or a tangled logic puzzle, it's like being forced to give the answer the instant you hear the question, out loud, with no scratch paper and no second to think. A reasoning model breaks that rule. Before it commits to a final answer, it generates a long private stretch of intermediate steps, a kind of scratchpad where it works things out for itself. It might restate the problem in its own words, try one approach, notice that approach isn't working, back up, and try another. Only then does it give you the answer. Nothing about the underlying network got bigger or was retrained. What changed is that the model is now allowed to spend more effort at the moment you ask. More computing, right there at answer time. That's the whole shift, and it's smaller than it sounds. Thinking is just compute spent thinking. Why should scribbling out steps make an answer more correct? Because each step becomes something the next step can build on. When a model tries to leap straight to the answer on a hard problem, it has to do all the work invisibly, in a single forward pass, and it often trips somewhere in the middle with nothing to catch it. When it writes the steps out, each one is laid down in front of it, and the following step can lean on what came before. The way you'd never multiply two large numbers in your head, but can do it easily on paper, one column at a time. This is the famous idea of chain of thought. Give the model room to reason in the open, and its accuracy on hard problems jumps, sometimes dramatically. And here's the striking part. On these problems, a modest model that's allowed to think at length can outperform a much larger model that answers instantly. The extra thinking substitutes for extra size. Effort at answer time trades against raw scale. Two different roads to the same mountain, and suddenly you have a choice about which one to take. So how do you teach a model to think well, and not just to ramble on for longer? This is the clever part. You don't hand it a textbook of perfect reasoning to memorize and copy. Instead, you let it try, generate its own attempts at a problem, and you reward the attempts that reach the right final answer. Do that at enormous scale, across millions of problems where the answer can actually be checked, and something remarkable happens. The model discovers useful reasoning habits on its own. It learns to double-check its own work, to catch an error halfway through, and correct course instead of barreling ahead. To break one big problem into smaller, easier pieces. Nobody scripted those moves. They emerged because they led to right answers and got reinforced again and again. It's less like teaching a student to follow a fixed set of steps, and more like training an athlete. You don't dictate every muscle movement. You reward the outcome and let the skill develop through practice. The result is a model that isn't just parroting reasoning it once saw in its training data. It's running a process it earned. Now step back, because this is much bigger than a trick for acing math tests. For years, there was essentially one way to make a model smarter: scale the training. More parameters, more data, more compute spent before the model ever met a single user. Reasoning opened a second axis entirely, scaling at test time, the moment of actual use. And it turns out this new axis has its own clean curve, just like the training ones did. Let a model think for longer, spend more compute per question, allow it more steps, and its accuracy climbs in a smooth, predictable way. That's genuinely profound. It means that when growing the model gets too expensive, and we saw last time that it does, you have another lever to pull. You can pour compute into thinking instead of into size. A smaller, cheaper model, thinking hard and long, reaching answers a giant model couldn't. The frontier stopped being a single number for how big your model is and became a trade. How much do you want to spend building the brain versus how much are you willing to spend each time you use it? But nothing here is free, and thinking has a real price. The obvious one is cost and speed. A model that generates thousands of words of private reasoning before it answers uses far more computing and takes far longer than one that replies in an instant. And you pay that every single time it thinks. So, in practice, you save the deep reasoning for the problems that actually deserve it, and let the easy ones fly by. Then, there's a subtler, stranger worry. That visible chain of steps the model shows you. Is it honestly the reasoning it used to reach its answer, or a plausible-sounding story it assembled afterward? If the real computation happens somewhere we can't see, and only a tidy narrative is displayed, then a chain we're trusting to catch mistakes might not actually reflect what happened inside the model at all, and a system that reasons privately for a long time before it acts is exactly the kind of thing all the safety work we've covered was built to watch. More capability, and more of it happening out of sight. Thinking makes these models genuinely stronger. It also gives them far more room to think in. That's reasoning, the second dial, where more thinking buys more intelligence, and the hard questions that come with it. If this clicked, subscribe. Next, every lab now claims their model is the smartest. So how would you actually know? The messy science of measuring intelligence.